Alright, this is Major in 2024, paper 22, O-Levels 5054 Physics. The grade threshold for this paper for an A grade was 44 out of 80, raw mark for B was 32 out of 80, and raw mark for C grade was 19 out of 80 marks. As we will solve together this paper, we will realize that this is not a difficult task to do. Okay, so first question is about momentum. He says that the front trolley is moving towards trolley B, which is at rest. So trolley B is at rest, which means it is moving at 0 meters per second. Trolley A moves towards the right side and rod enters the modeling clay so that they can embed together. Trolley A slows down and trolley B starts moving, and they're sticking together and they're moving towards the right side together. So this is something before collision, and trolley A embedded with trolley B moving together in the right side will be something that is going to happen after the collision. Now, figure 1.2 shows the speed time graph of each trolley individually. As you can see, the trolley B initially has 0 speed, and trolley A is approximately moving at a speed of 0.7 meters per second, which will come in handy later in the numerical questions. So in the first part, he says the trolley starts to collide at t 0.3, finishes at 0.5. The trolley are moving at the same speed after the collision. So the duration of the collision starts from 0.3, finishes at 0.5. State how figure 1.2. So you have to represent, or you have to discuss the graph itself to show what you're talking about. So state how this figure shows that during the collision, trolley B has uniform acceleration. You see, in figure 1.2, we need to associate that the gradient or the slope of this graph will be equal to acceleration. So once we've associated that, then we can comment about that the gradient in this section is constant. If the gradient is constant or uniform, then the acceleration is uniform or constant. Gradient is the steepness of the line, how steep the line is. So a straight line from this section to this section representing uniform gradient, thus uniform acceleration. So you have to mention gradient somehow to associate or to show the examiner that you do have the necessary knowledge for this. In part 2, we said describe how the graph figure 1.2 shows the magnitude size, the acceleration. Trolley B is larger than the magnitude deceleration of trolley A. Now, there are two arguments for this. Now, since we're looking for acceleration and acceleration is the gradient, we can argue that the gradient of the trolley B is greater than the gradient of trolley A. But for the sake of a student, for example, who may not be able to see this, who may not be able to figure this out just by looking at the diagram, because even to my eyes, it looks that probably, because again, we have to accommodate for the exam pressure, it looks like that they're probably the same. So if that is how you feel, how would you argue otherwise? You can see that the acceleration actually is dependent on the change in velocity divided by change in time. The change in time for both trolleys is exactly the same. So this is not the part of the discussion. The discussion boils down to acceleration being dependent on the change in velocity. Now, can we argue in terms of the change in velocity? Yes, we can. Trolley A has a speed of 0.7 and boils down to at this level, which is 0.4. So the change in velocity for trolley A comes down to 0.3 meters per second. Trolley B, however, is 0 meter per second at the start of the experiment or the collision, and at the end of the collision, it is at 0.4. So the change in velocity of trolley B comes out as 0.4 as it changes from 0 to 0.4. Now, since the change in velocity for the same time frame, velocity B or the change in velocity B is greater than change in velocity A, hence the acceleration of B would be greater. So I have used the argument with the values. I've given it preference because it is more solid. It is a better argument in terms of at least picking on the values, because when he says that use the graph or show on the graph or the graph shows, it's always a good idea to pick values and then refer to your answer. All right. You can pause the video and see what I've written down in terms of the statement, but I've explained to you what the basic argument is. In part 3, he says calculate the acceleration of trolley B when t equals to 0.4. Now, this is a common question. When we come to this graph and we locate where is point 0.4. So time 0.4 is actually at this location, which actually falls within the category when the constant acceleration is taking place. So what we can do is we can choose coordinates. This is the coordinate number 1, this is coordinate number 2, and then we can apply the formula for acceleration to find the formula for gradient to find the acceleration, because we understand that acceleration is the gradient. So the two coordinates we have over here is 0, 0.3, 0, and the upper coordinate, this one, will be 0.5, 0.4. You can either use the formula for the gradient, which is y2 minus y1 over x2 minus x1, or you can just straight away go towards this idea that acceleration is equal to change in velocity divided by change in time. So how much the velocity has changed? It changed from 0 and became 0.4 in a time frame of 0.2 seconds, which starts at 0.3 and finishes at 0.5. When you solve this, you realize that the answer is going to come out as 2. But we can't just write down 2. We have to make sure that the answers are in two significant figures, which should be written down as 2.0. The mass of the trolley A and the mass of trolley B is this. Show that. Now he's asking you to show, hence you have to show mathematically the momentum before the collision and momentum after the collision. So momentum before the collision, we can see that this mass into velocity. Only trolley A was moving, so only that data is being used. So mass of trolley A multiplied by the speed of trolley A comes down to 0.56 Newton seconds. When we move towards the after collision, we realize that they're both sticking together. They're both embedded with each other, as mentioned by the examiner in this question, that they are sticking together, which means that the masses should be added together. So that's why you will see that 0.8 is being added with 0.6. This is the mass. Sticking together, they will be added. From the graph, we can see that the after collision, the velocity was 0.4, the speed was 0.4. Multiplying this gives us 0.56 Newton seconds. So this shows the momentum before and after collision was equal, and hence we can say that the momentum is conserved during the collision. Part C suggests in another collision between the same trolleys, the rod and the modeling clay are not present. There is no cushion between them. There is no soft padding between them. Trolley A hits trolley B at the same initial speed, so the experiment is exactly the same as we were conducting before. So he says, explain why the force between the trolleys is larger in this collision. I will explain to you in terms of mathematics, but then you can pause the video and read the theoretical explanation as well. You see, force is equal to rate of change of momentum divided by time. Since we're conducting the experiment with same masses and same initial velocities, the change in momentum is going to remain the same. The values of mv and mu will remain the same. So force is not dependent on masses and velocities. Rather, force is dependent on the time frame when it happens. If it's going to happen suddenly, the force will be higher. If it happens with a delay, the force will be lower. We can see that the force is inversely proportional to the time taken for the job. Now, since the modeling clay is not there, there is no cushion, there is no soft padding in which the time of collision or the time of this process can be increased. You see, if you allow for a larger time, the force decreases. And the same idea is employed for airbags in the vehicles. Airbags deploy so that they can increase the time for your head to slow down. And as it is doing so, the force on your head reduces drastically, right? So the same thing is being mentioned or discussed over here. The time of contact during collision reduces because there is no soft padding. So since the time has reduced, although the change in momentum is pretty constant, the time for change in momentum is smaller due to rigidness of the trolleys, leading to a greater force on the trolleys because of this idea, because of this equation that we've already done. Question number 2 suggests that this is a pool of water, right? And there is the depth of the water is 0.8. So the only thing not mentioned on this diagram is 0.8 meters in terms of its dimensions. The density of the water is given as 1000. He says, show that the mass of the water is this. A very simple, straightforward equation, that is density is equal to mass over volume. Density is 1000 and mentioned over here. And the mass is what we're supposed to find out. So for volume, we have simple mathematics for this. So 2.1 multiplied by 4.0 multiplied by the height. So width multiplied by length multiplied by height gives us the volume. So 2.1 multiplied by 4 multiplied by 0.8. Then, since it is being divided by mass, we have to take this to the other side and multiply this with 1000. So the final answer will be 6720, which up to two significant figures will be 6700 kilograms, as shown. Then define pressure, again force per unit area, which is pressure equals to force per unit area. Definition simple. Calculate the pressure on the base of the pool due to the water. Now, the pressure for liquid has a formula that is rho GH. So simply put, rho is 1000, G is 9.8, and height or the depth of water or the actual depth of the liquid inside the container is 0.8. So the pressure at the base of this pool due to the weight of the water would be because of this 0.8. So this comes out as 7840, rounded off to two significant 7800. The other way around of this problem would have been to use the generic formula, the universal formula for pressure, which is P equals to F over A. Where is the force coming from? It is because of the weight of the water. Do we have some values for that? Yes. So the mass of water inside the pool is 6700. The G, which makes the weight eventually of water, is 9.8 divided by the cross-sectional area over which this force is being spread out. So the force is being spread out on the base of the container this way, right? So force of the water is coming this way, and this is the cross-sectional area which is being encountered by that force. That should be 4 multiplied by 2.1. This will be the cross-sectional base area. So 4 multiplied by 2.1 gives us 7816, again leading to the final answer as 7800 with no difference at all to the final answer. Your choice, you can choose any of the two methods. Part 4, the water in the pool initially at 10 degrees centigrade. The temperature increases because this much energy is transferred to the water, probably due to the heat from the sun because it's on the outside, or probably due to an electric heater, we don't know. The specific heat capacity is this. Calculate the final temperature of the water. You see, since he has mentioned the specific heat capacity, students quickly jump to the formula of mc delta T. Yes, this will be where the question is going to start, but you may forget about this one detail, that this is actually change in temperature. This is delta T. This is not the final temperature in some cases. You have to make sense of the question. So Q represents energy. We added 5.1 power 10 joules of energy in a mass of 6700, having a specific heat capacity of 4200, but we don't know how much temperature will change because of the investment of 5.1 into 10 raised to power 8 joules of energy into the system. Now, once you solve that, once you find the value of T, which is basically delta T, it comes out as 17.7 degrees centigrade, which means that no matter whatever is the initial temperature, there will be a change of or delta T of 17.7 till the final temperature. Okay, so is the initial temperature mentioned? Yes, it is mentioned that the initial temperature is 10 degrees centigrade. A change of 17.7, which raises the temperature, means that the final temperature should be 10 plus 17.7, which will be 27.7, rounded off to 28. Explain in terms of the movement of the particles how evaporation causes cool. Again, a repeated question. Particles with more kinetic energy escape the surface of the liquid, leaving behind particles with lower kinetic energy, causing cooling effect. You see, if we go back to the chapter of kinetic energy and kinetic model of matter, we realize the temperature is dependent on the kinetic energy of the atoms, again simplified to the speed of the atom itself. So what are we generally saying at this point? What you can also write down is the particle with more speed or higher speed escape, leaving behind particles with lower speed. Particles with lower speed. It will still mean the same thing. And kinetic energy and the speed are actually representative of the temperature, right? So since high energetic particles have left the system, low energy particles are left behind, it looks like that there is an overall cooling effect. This is what happens when you're sweating and you turn a fan on and you start feeling cold at the initial burst of air. Changes factor to the environment swimming pool causes increase or decrease the rate of evaporation. He says state 2 changes, give me 2 more changes in the same experiment which will increase the rate of evaporation. So apart from many, we have higher temperature. Of course, if you increase the temperature of the system, the bonds weaken. There are more molecules at the top surface with higher temperature, with higher energy, higher license or higher energy to escape. They can go easily, or leaving the system behind will be easier for them. You can cause or produce airflow, which will make space for more atoms to come into the vacuum or into the environment, again increasing the rate of evaporation, or lower the humidity. If the humidity is low, then there is more space for air particles to be saturated in the atmosphere, right? Question number 3, work, power, energy. He says we have a solar panel charging the mobile phone. He says complete the diagram below. So there is nuclear energy on the sun, again recalled from memory, electric field in the charger, and then electric current being produced, and then chemical energy stored in the battery. That's how charging works. Now, explain why the battery takes a long time to charge on a cloudy day. This is a question based on common sense because as the world moves toward solar panels and cleaner energy or cleaner sources of energy, it is expected by the students and the incoming students selecting physics that they understand that how solar panels actually work. So this is basically coming from that. And I hope that we understand what's the reason behind it. Less radiation, less infrared radiation coming from the sun or ultraviolet radiation coming from the sun reaches the solar panel on a cloudy day or at night, produces less electrical energy, hence less energy is available for the charging of the phone. Part B. After outside, the surface of the cell is warm, when it is switched off, the cell phone actually cools down. This is, I think we've experienced this as well. When we're using a phone while playing a game or using a heavy application, it generally heats up. And when you close it down, when you just put it on the table, it starts to cool down again. Name and describe the three processes. And again, a repeated question in terms of the checking of knowledge. So conduction will cause the phone surface to vibrate, and the phone itself or the atoms of the phone are vibrating at a high temperature when it is at a greater temperature. So those vibrating atoms on the solid surface actually collide with the air particles. When they touch the air particles gain that thermal energy and take it away from the phone. So one of the process of removing energy was through conduction. The next one is convection. As the phone heats up, for example, this is the phone that you have. The phone has heated up. Since it is heated up, the air particles that are close to the surface of the phone will start rising up due to lowered density, and a convection current will set up. Again, as a consequence, replaced by cold air on the outside or on the surrounding. So convection current set up as hot air rises and cold air replaces it. Then infrared radiation, which you may not be able to see with your eyes, but of course an infrared thermal detector can see them. So infrared radiation, which is happening at all times from hot bodies, from the surface of hotter objects towards the surface of or towards the environment, which is at a lower temperature. And it is happening in the infrared region. Even the heating effect of the sun is primarily caused by the infrared radiation coming from the sun when you stand in direct sunlight. So yes, some infrared radiation emitted from the surface of the phone, which is being emptied into the environment. It takes 4.5 hours to charge the battery with an average current of 300 milliamperes. Calculate the quantity of charge. So a very straightforward equation, which is I equals to Q by T. I've noticed in the past papers that he has stopped ignoring the equation Q by T and V equals to work done by charge. Students generally forget about them and just remember that the electricity chapter is all about Ohm's law, which is V equals to IR, or power, which is V equals to P equals to IV. So now he's started asking questions of these topics as well to remind you that no, if they're included in the syllabus, you must practice the questions as well. So he's asking us about the charge. So making Q the subject of the formula, we are left with IT. I is 300 milliamperes, so don't forget about the prefix. This will be 300 into 10 to the power minus 3. 4.5 is hours, should be converted into seconds by multiplying by 3600, which is definitely 60 multiplied by 60. So the answer comes out as 4860 up to two significant figures. This will be 4900. And of course, the unit is going to be coulombs. Question number 4 is from Leiden Lenses. He says, and by the looks of it, it looks like that the question is from total internal reflection. He says, what's the angle of incidence at point P? You see, the normal has to be drawn perpendicular to the surface, making an angle of 90 degrees with the surface. And if that is how the normal is being drawn over here, we will realize that the angle of incidence, which is supposed to be drawn between the normal and the incident ray, is supposed to be this theta. But since the normal and the incident ray are exactly in line with each other, the angle of incidence is going to be considered as 0. Some students might write this down as 90 degrees, but this is not 90, this is supposed to be 0. The next question is draw a normal. Now at point R, the normal is going to be at 90 degrees with the surface. So the surface or the boundary actually looks like this, and this is actually 90 degrees with the boundary. So this is how it's going to look like. State two conditions needed so that the light transfers. Again, he's asking you indirectly about the total internal reflection phenomena. And we understand that there are two conditions for them. The angle of incidence in glass in the denser medium should be greater than the critical angle set out by the refractive index. And the second point is that as a must, light should be moving from a more dense or a high density medium to a low density medium. For example, it could be going from glass to air, or from water to air, or from a material that has a high refractive index towards a material that has a low refractive index. For example, the refractive index is 2.1, going towards a material that has a refractive index of 1.7. Even in this case, this will be considered as a movement from dense to rare medium. Rare is another word for something that is less dense in comparison to the first one. All right. Part B, information is sent out using, again, this is another question in terms of repetition that recently started asking questions about the optical fibers. So please don't ignore the optical fibers and what are their advantages. He says that apart from the visible light that we use along optic fibers, there is one more type of electromagnetic radiation that we use to transmit information, right? So that is infrared, and one of the examples you might have seen is your TV remote controllers or the remote controllers you use to switch on and off your air conditioners. So infrared is also used for communication purpose. Suggests two advantages of using glass fibers rather than copper wires. In the olden times, copper wires were used to transmit data, phone calls, and internet access was on copper wires, but they shifted towards the glass fibers and optic fibers. What was the advantage? You can check out the marking scheme. There are many advantages written. I would recommend at least memorize 4 to 5 of them, which will help you in the next examination or which will help you in A levels. So it is more secure, it has less chances of hacking in comparison to, of course, copper, and more data can be transmitted for the same amount of fiber. You see, if there was one cable of copper, probably there could be only one call at a time happening on that line. But if the same size, same mass, approximately fiber optic is there, there could be numerous calls in a single fiber, let alone a bundle that is equal in mass of copper. That's why we said that it has more data. An initially uncharged rubber balloon, that means there is no charge on it, is being rubbed with a piece of cloth and there are going to be charges on it. It says complete the labels on the diagram. So the balloon gains electron is now negatively charged. Although this blank is empty, we understand that for this chapter, only electrons can be moved. Protons or positive charges do not leave their positions. So it must have gained electrons to become an overall negative charge body. So let's say that there are negative charges on the balloon right now. But where these electrons came from is from the woolen cloth or the piece of cloth. So it was uncharged as well, but due to the friction and due to the thermal energy produced due to the friction, the electrons have moved or left the piece of cloth and jumped onto the balloon, leaving behind positive charges on the piece of cloth as an overall positive charge. And again, the electrons have jumped, so woolen cloth loses electrons and becomes an overall positive charge or retains a positive charge overall or net positive charge. Explain why a balloon stays negatively charged for a long time. The balloon is made out of insulating material and it is difficult for the electrons to move away or across or through the insulating material. So they're just going to stay there for a long amount of time or for a long time because they have nowhere to go. If there had been moisture or if this had been a conducting sphere, then it would have been discharged easily. Rubbing the balloon causes the temperature of air rises or to air rise inside or the temperature of the air to rise. Explain in terms of particles of air why the volume of balloon increases when the temperature of the air rises. So this topic is from the pressure, volume and temperature of the gases. If he's asking about or discussing about temperature and volume, chances are that the pressure is going to be considered as a constant for this question so that V and T can be compared. V is proportional to T or T is proportional to V. If you increase the temperature, the volume increases. But why? This is an observation when we are cooking something in the pressure cooker at our homes. But why does that happen? You see, at higher temperatures, the air particles move faster, as we can understand that the temperature is proportional to the kinetic energy, which is proportional to the speed of the atoms. And this is true for the whole universe, not only for solid, liquid, and gas, but for everything. So now they possess more kinetic energy. Now, since they have more kinetic energy, the molecules collide with the walls of container at higher speeds, okay, and undergo a greater change in momentum. You see, force, as explained earlier, is actually rate of change of momentum. Momentum is dependent on mass and velocity. Are we changing the mass of the atom that is inside the container? No, it's the same gas, same mass, same liquid, same solid, whatever that may be. The atom's mass is not changing, but the velocity is changing because it is proportional to the temperature. Now, since V is being increased, the force will also increase, which means that the higher change in momentum, which is of course because of the velocity change, causes a higher force. This causes the pressure that causes the balloon to expand. You see, higher force, then P equals to F over A. Higher force causes higher pressure. Now, let's say if this is the balloon, the pressure inside the container increases and the pressure on the outside, which is from the atmosphere, is roughly constant. But since the pressure on the inside increases, or you can say pressure in is greater than the pressure outside, a force is exerted from a high pressure region towards a low pressure region, which causes the expansion of the balloon. This is the complete thought process, but writing this down would be good enough. Mentioning change in momentum, higher speed as temperature, and then higher force leading to greater pressure, which will cause the expansion of the balloon. Question number 6, he shows that there's a diagram. We have a supply, we have 240 and LDR connected in series. And he says the lamp is near a circuit. There is a lamp near the circuit. And of course, the lamp will be used to influence, the bulb will be used to influence the resistance of the LDR. If it's on, it will be low. If it's off, the resistance of LDR will be high. As we know, the resistance of LDR is inversely proportional to light. And we have to memorize this relationship. There is no denying it. So figure 6.2 shows current voltage of the LDR. All right. And once when the lamp is switched on and once the lamp is switched off. And we can also see the trend from this graph as well, that at the same voltage, which we will argue for the next part, when it is on, the resistance is going to be low, which means that for the same voltage, the current injection is higher. And when it is switched off, the resistance is going to be higher. So for the same voltage, the current produced or current actually flowing through the circuit is much lower, which denotes that the resistance of the LDR probably has become greater. So state Ohm's law again, a common definition, current is proportional to voltage while the temperature is constant, which gives us the equation V is proportional to I. Finally, V equals to IR. Explain how the graph lines in figure 6.2 shows that the Ohm's law applies to the LDR. So Ohm's law, as we've done in class, is VI characteristic, a straight line passing from the origin. It has to be from the origin because we have a direct proportionality. Why do we need to have a direct proportionality, and why is that so important? You see, when there is no voltage, when there is no potential difference, when there is no energy provided to the electric charge, there should be no current, and that is the law of the universe. If you provide no energy, then there will be no current. So graph is a straight line and it is passing from the origin. Both statements are necessary. If, let's say, for a filament lamp or a diode, the graph curves like this or like this, then of course this is not following Ohm's law. Okay, use values. Now this statement is important. You have to pick values from the graph to explain or at least give conclusion to your argument. The effect of light on the resistance of LDR. So a good idea would be to choose a single point. What I have done is selected 8 volts as my argument because I can pinpoint and pick out exactly what values I'm going to use to find the resistance. I could have selected 3, I could have selected 2, I could have selected 1. That is fine. But the gap between the values is too small to predict what values they may be at the moment. So at 8 volts, I used V equals to IR manually on the calculator and told the examiner that the current in the LDR is 0.06, again picked from the graph, but using V equals to IR, I found that it is 133 ohms. But of course, to two significant figures, I will refer that this as 130 ohms to offer when the light is off. Again, in line with our concept that the resistance is inversely proportional to light. When light is off, resistance is high, which is 130. And at the same voltage, when the light is on, the LDR has 0.1, leading to V equals to IR resistance of 80 ohms when the light is on, which means that the light has an inverse effect on the resistance of the LDR, which is of course this conclusion. He says with the lamp switched on, the LDR has 0.05, determine the current. Now since they are in series, the current remains the same. That's why we have to mention this. Then he says calculate the electromotive force of the cell. Now notice that EMF is not mentioned in the question, but we do understand that this is a fixed resistor and this is a variable resistor. He mentions that the current through the circuit is 0.05. So what we can do at least is find the voltage of the resistor itself, or the voltage consumption by the resistor, which will be IR. So 0.05 multiplied by 240. This comes out as the first value, that is 12 volts. So the resistor must be consuming 12 volts at the current situation. And since the same current is passing through the LDR, which is 0.05 amperes, the graph suggests that at 0.05, it should be, when the lamp is switched on, it should be at a voltage of 4 volts. You see, it is necessary to understand that we are going to look at the graph when the lamp is switched on, because he mentions that the lamp is switched on. We can't go for the next graph. So what I have done is shown to the examiner, even though that we are solving the part in the next page, but we should show with the dotted line what coordinates you are picking out for the examiner explanation. So I mentioned that the voltage across LDR from the graph at I equals to 0.05 amperes is V equals to 4. Now in series, we understand that the current remains the same, but the voltage divides. So if this is consuming 12 volts and this is consuming 4 volts, chances are that 100% the EMF is exactly 12 plus 4 or somewhat greater than that if you're considering the wires to be non-ideal. So it should be 16 volts. EMF, some of it is being shared by the resistor and some of it is being shared by the LDR. That's how series circuits work. So that's how you're going to write down that this is 16 volts. But explain your procedure, what you've done. Question number 7 suggests that the plotting couples, again a common question. He says mark the poles on the magnet. So south pole should be attracting the north pole, and the other, if this is what you figured out, then of course the opposite pole should be south pole. I've deliberately used different colors for them, but there is no compulsion because you will be doing this with a ballpoint pen or a pencil. So we've done the first question. Describe, okay, there is a piece of paper in the magnet. Now, this is a common question in terms of ATP and a repeated question. How to draw a field line from one point to the other point. So I'm going to show you a question or the answer to the question. This is what we generally write down for the examiner for this question. You can pause the video, make notes of this image, and you can write this down as your answer in the question. As you will see, this is what we've done. We say that mark the north end of the compass with the pencil, right? So this is where we put a mark, right, with a small arrow, if that's what you want, or you already understand the direction of magnetic field. So we put a mark over here. Then we replace the compass again. We pick it up, we replace the compass over here, but we make sure that the tail end of this compass, for example, the south pole, actually aligns with the mark that was placed by you previously. Then we again make a marking over here on the outside with the lead pencil. Then we replace the compass again at this location, making sure that it is aligned. The south is aligned and the north is pointing towards a new direction. Again, we draw an arrow over here, replace the compass, and keep on doing this until we reach the other end. This is how the question goes. That's what I've written down in this statement. You can pause the video and see what we mean by each statement. You may have a different writing style. It's totally up to you. There is no compulsion. Part 3. Describe how to use the compass in 7.1 to determine the magnetic field at point P. Now, what are we supposed to do at point P? What can we do at point P to find the magnetic field? You can use a compass over here, and wherever the compass points towards, that will be the direction of the magnetic field at that point P, which is mentioned in the written statement, that place the compass at points P, and the direction of the magnet can be matched or can be drawn with the pencil, and it can be shown by the compass. Question number part B. He says that the apparatus shows a magnet and a coil. So for the first impression it gives me is that it must be from the Faraday's law of electromagnetic induction. He says that it produces electrics and alternating current, which is the purpose of the Faraday's law primarily. He says the magnet moves in and out of the coil. Explain why the current is produced in the magnetic as the magnet moves. Now, please be advised, he's asking you about the current. He's not asking you about the EMF. You may end your answer at EMF, but you must answer that voltage or EMF leads to current. This should be your final conclusion. Now let's see what's going to happen. So when you move the magnet, it cuts the magnetic field. It cuts the magnetic field, or the magnetic field cuts the coil itself. And when a magnetic field cuts a conductor, it produces an induced EMF, which was found by Faraday's, and then it eventually came to be known as Faraday's law of electromagnetic induction. Now, once you've landed to the induced EMF, you must mention why there is current. So then you will mention that EMF in a closed circuit produces or causes current, which is read by the ammeter. You see, if this had been just about voltage, we would have ended our question at this point. But since it's about current, we need to involve this statement, because although the question is for 2 marks, this is sufficient for 2 marks, but I've seen this question asked for 3 marks. So I'm adding information, adding one more extra information for that 3rd mark, that if you encounter that question, it may help you. Part 2, describe the movement of the magnet produced an AC frequency of 0.5. This is an interesting question. See, frequency is equal to 1 over T. Now, if you want to find the time, this would be 1 divided by 0.5 equals to 2 seconds. What does that mean? It means that it should be moved in, it should be moved out, but in a total time frame of 2 seconds. If you do that, then you will be generating a frequency of 0.5 hertz. Right? Okay. So the next part will be describe how the center zero ammeter shows that an AC current is being produced. Now let me show you an animation for this. As the magnet is moved, you can see that the voltmeter that is connected is moving left and right at the same time. In which direction it is moving, why it is moving is not important. What is important is that due to the electromagnetic induction, due to the Faraday's law, due to induced EMF, sometimes the current is clockwise, sometimes the current is anti-clockwise, which is a distinct feature of an AC current. So he says, what are you seeing? What will you observe, which will represent that this is an AC current? So sometimes it's positive, sometimes it's negative, that represented by a center zero needle, sometimes going towards the left, presenting negative current, sometimes going to the right, presenting positive current. And negative and positive related to the current is just representing its direction. There is no concept as negative current. We only assume that it is moving in the opposite direction. That is what it represents. So it oscillates between a positive and negative value. And this is what a center zero ammeter looks like. It has a 0 at the center, right? It's 0 at the center with some values -1, -2, -3 over the left, +1, +2, +3 over the right. Explain why increasing the frequency of AC also increase the magnitude of induced EMF. You see, if you do this process, if you move the magnet faster, you are cutting the coils at a faster rate. You see, the EMF or the induced EMF, for that matter, depends on 2 factors. The change of magnetic flux, which we referred as the cutting of the coil, divided by the time taken for the process. If you do the same thing, which he says that increasing the frequency of AC, if you keep your movement same, but you increase the frequency, you increase the speed, you increase the probability that you're doing it more quickly as compared to before, time of the cutting of magnetic field decreases because you're doing it more quickly. You see, previously it was done in 2 seconds. Probably now you are doing the same thing in a time of 0.1 seconds because you're moving your hand faster. If you're doing that, then naturally the induced EMF will increase. So greater change in magnetic flux leads to a greater magnitude of induced EMF. A very simple, straightforward answer. Question number 8 is from space physics, I guess. Yeah. So it says supernova is formed. What is the meaning of supernova? Explosion of a red giant at the end of its life. This is supposed to be memorized from the slides or from the lessons. The life cycle of a star. This is a common question. Describe how a protostar is formed. Again, this is the starting point of the formation of a star. So how does it become a star? What is the initial stage of becoming a star? So a cloud of dust or cloud of gas collapses or implodes on its own mass or its own self due to its own gravitational pull. The gravity is so strong that it pulls everything together, causing an increase in temperature and in the cloud of gas, right? So this is called a protostar. This is happening before any fusion of hydrogen to helium can begin. The star is still collapsing on itself. The temperature is increasing. The pressure is increasing. Eventually, the fusion will begin. Our sun is circular orbit. It has a name of the galaxy, and we understand this Milky Way. We understand this. The distance measured state what is meant by the light year. Now, contrary to the common belief, if you read the notes and read the chapter, you will realize that the light year is not time, but it's distance traveled by light in 1 year if it was moving at its maximum speed in vacuum, which is 300,000 or 3 × 10⁸ meters per second. The time taken of one complete orbit of the sun around a black hole is this time, and the distance from the sun is this much to the black hole, and 1 year is this, and speed of light is this. Calculate the speed of the sun. Now, let's say that this is the black hole. This is black hole, and let's say this is our sun with our own orbit, with our own galaxies revolving around this black hole like this. Now, the formula for this orbital velocity is v equals to 2 pi r by t. So it's easy to figure out 2 and pi and the time taken for the light or the sun to travel the black hole. So figuring out r is the primary concern, is the primary problem, right? So r is the distance from the black hole up to the sun. So how do you calculate that? So the distance is mentioned as 26,000 light years. So simply this 26,000 light years, the total value multiplied by the speed of light multiplied by the time of 1 year in seconds. You see, this is speed multiplied by time, which gives us distance. But since we're dealing with a standard value of 1 light year, that is why this represents 1 light year and this represents 26,000. That's why r is actually equal to this. So then we replace the value of r in this formula, which is 2 pi into r divided by the whole process takes a time of this much. So divided by t gives us a value of 214,833 meters per second, rounded off to 2 significant figures. This is what it becomes. Written as a standard form will become 2.1 power 5. Question number 9. Alpha particles are sometimes emitted from the nuclei of radioactive elements. We understand that this emission is both random and spontaneous. Describe what is meant by spontaneous. So there are two aspects of being spontaneous. The first one is that the emission happens on its own. What does that mean? It means that you didn't start it. You cannot start it from, or it didn't happen from an external factor. It happened on its own, and it happens without any prediction. So this is the first part of the answer. The second part is that how is it not affected by the external factors? What are those external factors? The first one is temperature. If you increase or decrease the temperature of the radioactive sample, which is causing or which is emitting alpha, beta, or gamma, it does not affect its rate of emission. You increase the pressure, it does not have any effect. You produce another radiation close by it, it has no effect on the primary radiation coming from the first source. And if you add any chemical, let's say acid or base, will it increase or decrease the rate of reaction? No, it does not affect the rate of emission. Part B says describe the composition of alpha particles. So we must state that it contains 2 protons, 2 neutrons. But how is it different from an alpha particle? And why do we call this an alpha particle? Because it is a helium nucleus which is stripped off of its electrons. So it's just the nucleus itself. There are no electrons. That is when we call this an alpha particle. No electrons, 2 protons and 2 neutrons. Alpha particle detected by cloud chamber and sparks produced by the spark counter. He has given you a choice, either draw a cloud chamber or either draw the spark counter. Spark counter seems more familiar. There is a definite standard. There is a definite, you can say, a diagram for this. So what we effectively do is that we have 2 plates connected at very high potential. One of them at 0 volt, one of them at, let's say, 500 volts. Positive or negative, it doesn't matter, right? So the upper grill is a mesh, is like a gauze-like structure, like a filtration or like a net through which radiation can pass through, right? So the radioactive sample is brought closer to it. Whatever radiation it may have, let's say it is emitting alpha, it is emitting beta or gamma. Gamma, of course, will be difficult to detect because it has almost no ionization. So when it does, the air particles that are present between the plates, they are ionized and distributed or destroyed between positive and negative particles. Now, based on static electricity that we have done, these particles are now separated. The positive will go towards the negative and negative will go towards the positive. And when this happens, this causes an electric current. That electric current is seen as sparks or sparks between the plates. This is the spark counter. So it can show you, or it can represent how much activity a radioactive sample is producing. Is it highly radioactive or is it just mildly radioactive? Okay, so we explained this process a bit, that radiation ionizes the air between the plates. Charges separate between the plates due to high voltage, and this leads to sparks being observed upon exposure of the radioactive source. Describe how the emission of the alpha particle is shown as random. Now, randomness is purely based on fluctuation, that the radioactive emission is so random, is so unpredictable that we can't predict what's the next amount of radiation that is going to come through the source. So spark counter's reading fluctuates, and you see that in the lesson you might have done that the decay curve looks like this, but this is an average decay curve. The true decay curve, which I've explained many times, actually goes something like this. Sometimes greater than the average value, sometimes low, sometimes greater, sometimes low. This fluctuation represents that the radiation coming from the radioactive source is random. We can't predict that the next moment will it be higher or will it be lower. And it is happening on its own. Everything is happening on its own, right? Part 3, a numerical question after a very long time. So a radioactive source produces 120 tracks, can be taken as counts per minute, can be taken as the standard value that, okay, it is producing a radiation of 120, or it's the radiation level or emission is at a level of 120 tracks in 1 minute. And after 6 hours, we see that the radiation has reduced to 15 tracks, which means that the radiation is undergoing the process of half-life. So he says the total process takes 6 hours to do. First, we need to figure out how many half-lives are involved in doing so. But do we need to worry about the background radiation? You can see that he mentions that without the source, when there is no source, no tracks are produced, which means that the background radiation is not existing. So we don't need to worry about this. This is exactly coming from the source only. So starting point, 120 divided by 2 gives us 60, then 60 divided by 2 gives us 30, 30 divided by 2 gives us 15. So we have our starting criteria and we have our ending criteria, and we realize that the number of half-lives is 1, 2, 3. So it got reduced or it got halved 3 times in a process or in a time frame of 6 hours. So 3 half-lives took 6 hours. So then 1 half-life will be of 2 hours. Again, simply dividing 6 with 3 will give you 2. So again, we can't write 2. We'll have to write down 2.0. This will be your final answer. One thing that I would like to bring to your attention at the end of the paper is that out of these 80 marks, 53 marks are for theoretical and reasoning questions. Why is this? Explain this, explain that. And only 27 marks are with reference to the numerical questions. And even out of those, half questions are straightforward and half of them are based on reasoning. Reasoning in terms of why mass is taken this way, why energy is taken this way. Very few questions are straightforward, even in this scenario. And even so, after solving the whole paper, I can go back to the threshold. We just need approximately 50% of the marks to score an A grade, which should be a cause of motivation for you guys, that if you're doing this paper at your home and you're checking the examination yourself, if you are going more than 44 marks, if you're getting, let's say, more than 50 marks, you should be in the safe zone. I would advise you that if you want to have an absolute guarantee, then at least 60 marks should be taken. If you're checking the paper on your own in your examination, then you can be at some peace of mind that you may get an A star or an A. But again, these thresholds are mentioned for your motivation. I hope this helps.